Today we're going to be looking at solving trig equations again, but today we're going to be looking at when we have multiple angles. So yesterday we just looked at something that was like sine of x equals 1/2 or cosine of x equals root 3 over 2 or something like that, and it was just the variable of x on all of your problems. Today we're going to look at when you have something like sine of 2x equals 1/2 or cosine of x over 3 or 1/3 x equals root 3 over 2, or something like that where there's a number in front of the variable next to, or of the angle, okay? So, for example, we still have the same two instructions that we had yesterday, where you could find all solutions or you could find in between 0 and 2 pi. So, I'm going to show you both again. So, find all solutions. My phone's on silent, but the alarm still rings. Find all solutions between, between. I was combining the two of them. Find all solutions for 2 cosine 3t minus 1 equals 0. Okay. So I'm going to start off a similar way that we did yesterday, where I'm going to get the cosine by itself first. So that's our first thing that we want to do. So I want to get rid of the 1 and I want to get rid of the 2. So I'm going to add the 1 to the other side. So I have 2 cosine 3t equals 1. So I'm going to divide by 2 to get rid of the 2 in front. So I have cosine of 3t equals 1/2. If you want, you can go straight from here to here. That's acceptable as far as showing where it goes. So now, what we did yesterday was we looked at this and we said, well, the cosine's the x value, so the x value has to be 1/2, so this is root 3 over 2. Since it doesn't start with root 3, that means that our reference angle is 60 degrees. 60 degrees in radians is pi thirds. And then we look in our quadrant and I say all students take calculus, and I look, since this is a positive 1/2, the cosine's positive in the first and the fourth quadrant. So I want to pick my pi thirds values in the first quadrant and the fourth quadrant. So I would have the variable, which in this case we're going to look at 3t, is equal to pi thirds plus 2 pi k, and 3t is equal to 5 pi thirds plus 2 pi k. So you still solve the same way, except for now your angle is going to be a number times by the variable. So now what I do after I've solved and found the two angles that work, I'm going to get the t by itself. So to get rid of multiplying by 3, I have to divide by 3. However, since I have a fraction on the right side, I'm going to think of it as multiplying by 1/3 instead. If you want to do divide by 3 and then flip and multiply, that's totally fine as well. So here this goes to t. So the 1/3 is going to distribute to both of these. So I have 1/3 times pi thirds is pi ninths, and 2 pi k times by 1/3 is 2 pi thirds k. I'm going to choose to write it like this. You can do 2 pi thirds or 2 pi k over 3. But when I'm trying to plug in my values of k, which we're going to do in a few minutes, it's kind of easier to look at it like this, I think, so that's why I do it that way. But either is fine. So on the right-hand side, we have t equals, I'm going to multiply, so I have 5 pi ninths plus 2 pi thirds k. Now, if I said find all solutions, then you're done. See clearly, that's what you're going to hope for, is that it says find all solutions. However, I have to teach you all things, so we have to do the other ones as well. So this would be all solutions. Okay. If I asked to find where t was in between 0 and 2 pi, okay, then you actually have to plug in values of k. And this becomes annoying because of the fact that you can end up with a whole bunch of answers because of the fact you divided by something. So now you're adding something less than 2 pi. So you have to add a whole bunch more to actually get one full revolution around. Okay. So if I plug in k equals 0 for this equation that we have, I'm going to have pi ninths plus 2 pi thirds times 0, which is just going to give you pi ninths. If I plug in a 1 for k, I'm going to get pi ninths plus 2 pi thirds times by 1, which is just 2 pi thirds. So really, if you get a common denominator, this is really your common denominator between 3 and 9 is 9. To go from 3 to 9, you multiply by 3, so the top is 6 pi ninths. Okay? So I'm going to do pi ninths plus 6 pi ninths, which gives you 7 pi ninths. Now notice, to go from pi ninths to 7 pi ninths, I went up by 6 pi ninths. So what you're really changing in between each one is you're adding 6 pi ninths, or this 2 pi thirds k value, with a common denominator of this over here. So rather than plug in 2 and say this is pi ninths plus 4 pi thirds and then find a common denominator, I'm going to choose to say this is really just plus 6 pi ninths, and that's going to give me the value of 13 pi ninths. Okay? So then if I plug in k equals 3, I'm going to add another 6 pi ninths onto here rather than saying, oh, I already multiplied by 2 there. I was thinking I hadn't put the 2 there, but I didn't. Already did that. So then I do 13 pi ninths plus 6 pi ninths, which gives you 19 pi ninths. Now notice it says we're going in between 0 and 2 pi. 19 pi ninths is bigger than 2 pi, right? Because 18 pi ninths is 2 pi. So I don't need this one. But I do have this answer, and this answer. But that's only from this equation that we have up here. So I have to do the same thing to this equation and plug in k equals 0, 1, 2, and 3, and so on until we get past 2 pi. Okay, so if I plug in k equals 0 for the 5 pi ninths one, I'm going to have times by 0, so I have 5 pi ninths plus 6 pi ninths k. Notice it's the same common denominator that we're adding. Okay. So our k happens to be 0 in this case. So then I just get 5 pi ninths. So notice I'm still adding the same thing from this equation to this equation. So if I plug in 1, I'm going to do 5 plus 6, which gives you 11 pi ninths. And then I'm going to plug in k equals 2. So if I add another 6 pi ninths to that, I'm going to get 17 pi ninths. If I do k equals 3, I'm going to do 17 pi ninths plus another 6, which gives you 23 pi ninths. And 23 pi ninths is bigger than 2 pi, so I'm not going to worry about that one. Okay, so notice all of my answers now are pi ninths. We'll put them in numerical order. I'm not going to really care if it's in numerical order. Typically I would write this and this, but for this problem we'll do it in numerical order. So I'd have pi ninths, then I would have 5 pi ninths. On a multiple choice test though, they do put them in numerical order, just so you know. 7 pi ninths, 11 pi ninths, pi ninths, 13 pi ninths, and 17 pi ninths. So these are your solutions that are in between 0 and 2 pi. For your t value, which is consequently why it becomes annoying because you get a lot more answers. But that is the process that you do it where you plug in this. We're going to use the same idea later when we come across polar numbers, but just keep in mind that if you get this value, so that has a common denominator, that's really what you're adding in between each one of your answers. That makes it slightly faster. Okay, so if we look at one, that's the tangent. If I have 3 tangent of x over 2 plus 3 equals 0, so I would subtract the 3 and then divide by 3, so I have tangent of x over 2 equals 1, and it's negative 1 because I subtracted the 3 and then divided by a positive 3. So the tangent, I have all students take calculus. The tangent is negative in the second and the fourth quadrant. The tangent is 1. That means that your y value and your x value have to match. The only place where it matches is your root 2 over 2, root 2 over 2. So it's a 45-degree reference angle. So in your second quadrant and in your fourth quadrant, your x over 2 is going to be equal to 3 pi fourths plus 2 pi k, and x over 2 is going to be equal to 7 pi fourths plus 2 pi k. Notice that in order to find in between 0 and 2 pi, that you have to use all solutions part, the plus 2 pi k, to get to all of the answers that you need. So it's very important that you remember the plus 2 pi k on your multiple angles one. Okay, so on this one I have to multiply by 2. So I get x is 3 pi force plus 4 pi k. And I'm going to multiply by 2. So I get x is... oh, I didn't multiply by 2 on this part. Let's try again. If I multiply by 2 on both of these, because you have to distribute, I'm going to get 3 pi halves, because the 2 and the 4 cancel. So I'd get a 2 on the bottom here, plus 4 pi k. And then, same idea here, have to multiply to both of these. So I get 7 pi halves plus 4 pi k. Now, the one thing that's nice about tangent, and it only works with tangent, or if you have, like some of the ones that you were doing yesterday, if you took the square root of something and you had, like sine squared equals root 2, or if sine squared equals 2 over 4. Well, no, that wouldn't work either. But you would end up with the square root as plus or minus, and you would have all 4 in these quadrants. That would be another case where you could use it with sine and cosine. But with the tangent, notice these are pi apart. So what I can do is, rather than write 2 answers, is that I can say, well, these 2 answers are really pi apart. So I can say that, I'm going to have to write it up here. So I could do 3 pi force, I could have x over 2 is equal to 3 pi force plus pi k, because if I do 3 pi force plus pi, if I add pi to this, which is 4 pi fourths, then I get 7 pi fourths. So then I could solve this equation, and I could multiply by 2, so then I would get, we'll do it over here, x equals 3 pi halves plus 2 pi k, right? So then I would get this, but rather than have plus 4 pi k, it would be plus 2 pi k. So rather than have 2 equations and plug in things to 2 equations, I can shorten it and have 1 equations and just representing both parts here, which is nice. So if we plug in k equals 0 here, then I get 3 pi halves. If I plug in k equals 1, I'm going to have, this is really 4 pi halves, okay? So then if I plug in 1, I'm going to have 3 pi halves plus 4 pi halves, which is 7 pi halves. But notice 7 pi halves is past 2 pi, so I don't have that one that I include. So if we look at doing this equation, if I do 3 pi halves and I plug in 0, I get 3 pi halves. If I plug in 1, I'm going to have plus 4 pi, which if you're adding 4 pi, you're obviously going to be past 2 pi. Same idea over here. So then I have that. And then if I have 7 pi halves, if I plug in 0, I have 7 pi halves, which notice 7 pi halves is going to be past 2 pi already. It is greater than 2 pi. So I don't use this one. So they give you the same answers whether you do it with the 2 equations or the 1 equation. So it just shortcuts your answer to 3 pi halves. Okay. The other thing that we can look at is that we can see, or we can use identities to help us solve some equations. So for example, if I give you 2 sine squared x plus, no, not x plus, x equals 2 plus cosine x. Okay, well, I have a sine squared and I have a cosine to the first power. So you should kind of think about factoring, but the problem is that this is a sine and that's a cosine, so I can't do any factoring unless they're the same function. Well, we have the Pythagorean Theorem that says sine squared plus cosine squared equals 1. You really ought to have that memorized by now, FYI. So I can change sine squared to be 1 minus cosine squared, if I subtract the cosine to the other side. So what I'm going to do is plug this in place of sine squared. So I'm going to have 2 times 1 minus cosine squared equals 2 plus cosine of x. So when I distribute my 2, I have 2 minus 2 cosine squared x equals 2 plus cosine x. Okay? So remember when you're factoring and you're solving by factoring that everything has to be on one side. So I'm going to subtract the 2 and add the 2 cosine squared. You could easily subtract the 2 and subtract the cosine x. It doesn't really matter. Typically you have your cosine or your squared value positive, so that's why I chose to do it that way. But it still doesn't matter. So 2 minus 2 is just 0. And then I'm going to have 2 cosine squared x plus cosine x. So now I have everything on one side, so now I can factor. So I have a common factor of cosine, so I'm going to take out the cosine of x. So I have 2 cosine x plus 1, and these are both equal to 0. So now this is like the problems that you did yesterday where I set the cosine of x equal to 0 and 2 cosine x plus 1 equal to 0. So this simplifies to cosine of x is -1/2 because I take the 1 to the other side, then divide by 2. So now I think, well, where's the cosine 0? Well, that means that the cosine has to be, or the cosine is the x value, so my x value is going to be 0, and I could either have 0 plus or minus 1. So that happens at your axes, at pi halves and at 3 pi halves. So x is going to be pi halves and 3 pi halves. And x is going to be, for the cosine, of -1/2. We have all students take calculus. The cosine's positive in the first and the fourth, so it's going to be negative in the second and the third. The x value would have to be -1/2, so I would have √3/2 as my y value, which means that's going to be a 60-degree reference angle because it doesn't start with √3. So 60 degrees in the second and the third quadrant is going to be 2 pi thirds and 4 pi thirds. Now I could also do the same thing and say find all solutions. So if it was find all solutions, I would have to do the pi halves plus 2 pi k and 3 pi halves plus 2 pi k. Notice that these are pi apart, so I could have really written pi halves plus pi k, kind of like we did with the tangent one. So you could have one of these. And then I would have to do 2 pi thirds plus 2 pi k and 4 pi thirds plus 2 pi k. Or n. I can't remember if they use n or k in your book, but there's the same thing. They mean integers. So you could either have these for your all solutions, or you could have these for your solutions between 0 and 2 pi. Okay? Let me show you another one that we could do. If I give you one that is 2 sine x cosine x equals -√3/2. Okay? Now, this is problematic as well because I can't set one of these equal to √3/2 and the other one equal to √3/2. It doesn't work that way. So I can't factor anything out. I can't add one to the other side. If I can't divide anything, that would be weird. So the only thing left to think about is your identities. So this one should be slightly familiar to you at least. This is your double angle identity. So if you look on your yellow sheet under double angle, the sine of 2x is 2 sine x cosine x. So I can change this to the left-hand side of this identity that we have. So I can write this as, sine of 2x equals -√3/2. And then this is like the problem that we did just a little bit earlier on where I have a multiple angle. So the sine is positive in the first and the second quadrant, which means that it's going to be negative in the third and the fourth quadrant. Since the sine is the y value, my y value is √3/2 and it's negative. And so that's 1/2, so that means that this is a 60-degree reference angle because it doesn't start with √3. So 60 degrees in the third quadrant and the fourth quadrant is going to be 4 pi thirds. So 2x equals 4 pi thirds plus 2 pi k, and 2x equals 5 pi thirds plus 2 pi k. That's in the fourth quadrant. So now I solve by dividing by 2 or multiplying by 1/2. So I get x is 4 pi 6, which reduces to 2 pi thirds, plus pi k. And then if I multiply by 1/2 on this side, I get 5 pi 6 plus pi k. Okay. So then if I want to find the solutions between 0 and 2 pi, I have to plug in k is 0, k is 1, k is 2, and so on and so forth. So this, in terms of a common denominator, is going to be 3 pi thirds k. Same thing over here. No, well, we have 5 pi 6. 2 pi thirds. So this one is going to be 6 pi 6. Okay. So I'm going to plug in 0, and I'm going to get 2 pi thirds. When I plug in 1, I'm going to have 2 pi thirds plus 3 pi thirds is 5 pi thirds. And if I plug in 2, I'm going to have 5 pi thirds plus 3 pi thirds, which is 8 pi thirds, which is past 2 pi. So I don't care about that one. If I plug in 0 here, I have, 0, I'm not plugging in. Right. So if I plug in 0, I get just 5 pi 6. If I plug in, that's what I was trying to write, k equals 0. There you go, gives you 5 pi 6. If I plug in 1, I get 5 pi 6 plus 6 pi 6, which is 11 pi 6. Okay. If I plug in 2, now you should notice this is really close to 2 pi, so if you're going to add anything more than 1 pi 6 to it, then it's not going to work out. Just as a side note, you can stop there if you realize it. If you don't, then obviously do it until you figure it out. But if I do 11 pi 6 plus 6 pi 6, it's 17 pi 6, which is greater than 2 pi, so I can't do that one either. Okay? So the only other way to do ones like these is to use an identity. So you can use your Pythagorean identities, and then factor it. Make sure if you're factoring anything that you get everything on one side, and then factor. Make sure if you ever have a setup like this where you have some on one side and some on the other, that you put everything on one side and you factor, rather than divide by something. If you try and divide by something, like here, if I were to pretend the 2's weren't here, so if the 2's weren't here and I tried to divide by a cosine, you would miss some answers because you divided by a cosine. So rather than divide, you want to factor it out and set that factor equal to 0 and solve. Okay, so that's what you need to do.